Thank you all so much for joining. My name is Anju Mercian. I am one of the directors with WomenWhoCode Silicon Valley chapter, and we have Helena, Sumana, and Deepika online here. Helena, they're all going to be volunteers, and if you have any questions, they're going to help you out. If you're unable to join or any issues, please please place in Slack your question. So if you want to join our community, you can follow us on Slack, Twitter, our website is here, all of the information is here. So we also will share all of the links here on Zoom. So Sumana, Helena, I think they'll be sharing all of the links on your Zoom chat. If you have any questions, please ask on Q&A session, because we can archive that, and chat session is only for any doubts that you may any doubts on the Slack or the community you may have, or general chat. Any questions on the Q&A, please? And thanks to our sponsors, Home Depot. If all of you could help retweet the tweet and thank our sponsors for helping us host this through Zoom. We have more than 100 participants that have joined. Yeah, 121. That's awesome. Thank you all for joining. And thanks to sponsors. And please, if you could help retweet, Sumana will be sharing the Twitter tweet. So if you could help retweet for us, that would be fantastic. So this is the mini data science bootcamp that we started on March 27th, and this is the second one. So, and then there will be one more which we'll finish up with the creating and comparing ML models. And today we'll be talking about the statistics, basically the exploratory data analysis. We'll be talking about it today. We also have an offset session that's coming. If you can look out in Slack, we have a post like a survey that we're trying to figure out when is the best time for most of you. So if you're already on part of our Slack, you can really choose the time that you want, or get your friends to choose the time that they want. That would be helpful. Okay, and if you have missed the part one, we already have the recording, and we will share the recording. And by the way, this meetup is being recorded. So we're just giving you a privacy information. So if you don't want to talk or use your voice, just to let you know, this is being recorded, and all of these links will be shared on chat and also on Slack. So you can go to visit the recording if you haven't already, and the Google Colab notebook is already shared. And today we'll be talking about cleaning, statistics, and visualization. So basically the exploratory data analysis. We will be starting off with we'll be starting off with the regular Titanic data set. And then we'll go a little bit of another data set, and then we'll have your turn, which will be properties. Sorry about the train noise. We live right next to the train track. Yeah, so that's about today. And if you have any questions, please ask on the Zoom's Q&A. We have Helena, Deepika, and Sumana that's here to help you out with any questions. And if I'm able to get to the questions while going through the code, I'll do that. And one of them will interrupt me if there's any major question that you've asked and you're stuck with any issues. So, and please, if you have interest in any questions that have already been asked, you can just upvote the questions, and that will also be helpful. So you can get to the questions first. If you have any questions, Q&A. If there are anything else that you have, any issues, you can use the chat, and they are being monitored. Okay, so I think we are ready to get started into a collab notebook. Before we get started, let me see if there's any questions. Everybody's audio is turned off by default. That's how we have. That's how we are doing it. Everybody are muted by default. So to get started, if you could use this bit.ly link and copy this copy the notebook. So if you click open the bit.ly link. If you open the bit.ly link, it will open up to a Google Colab, and if you could like copy it to your drive, if you're using, don't. So many people. Okay, and if you open it with Google Colab, uh, the, the drive will pop up, and then you can make your own. This is this is shared only for viewing. So if you just copy it, you will be able to run it. So if you have any issues, please respond on chat and let us know if you're facing any issues. Yeah, open with Google Colab on the top link. You want the sharing the bit.ly link here. Can everybody like have everybody been able to go to the data to the Google Colab? Just let us know. We're going to go over the all famous Titanic data set just as a like as a that's the best data set that's available. That's good for EDA. But we also have like your turn, the data set which is a properties data set for the NY zip code, and we also have a crime data set for you to practice too. If anybody have any issues, please request us in chat, and we have people to help. Yes, I would zoom on the page. Trying to zoom on the page. Is this good enough? Oh, that was too much. Okay. Okay, perfect. Okay, so let's get started. I think nobody has any issues. I don't see anybody. Yeah, the bit.ly link. How to open the bit.ly link? So you just copy paste the link to the like Google Drive or IE, and then when you open it up, you should see a link that says open with Google Collaborator. And if you click on that, it will open. Okay. Marijuana, I think this name. You don't get that. Just wait for a bit. I think since everybody are trying, there is like a time delay. It should be on top. There's a little time delay, I think, because there's traffic out to that, and so it's taking its time. But it should show up. There's no option as Google Colab. Like hover over it, maybe it'll show up. It's showing up for me, so I'm not sure. Okay, so okay, so we have Adiola asking, did you download the dataset to your system? No, actually I uploaded it to a Google Drive, and then I'm using Google Colab. I didn't do it on my system, it's on the cloud. Yeah. You can actually directly go to it, but what I did was I actually downloaded it. You can actually link it if you have it in GitHub also, you can link it, but I downloaded it from the, like what Project says is also you can do, but I downloaded it and uploaded it to in my Google Drive. if you're still facing issues. Oh yeah, if you don't have Google Colab, you may have to add Google Colab to your Google Drive. Yes. So thanks for bringing it. Yeah. Okay. I think. Okay. So I'll get started, and if you have any questions, you can just holler to Helena, Sumana, or Deepika, and they will be able to help you. Okay, so this is what I did. I actually downloaded from the Titanic data set, the Titanic data from this Kaggle data set, and I uploaded it to the Google Drive, to my Google Drive, under data. Like this is my folder space, and this is where I downloaded it. And this what I've done here is I'm actually mounting it to the Google Colab Drive, and mounting my drive, G drive. I think I'll have to okay. So when you actually do that, okay, my drive is already mounted, but usually when you actually do that, you get a link that you'll have to go to and open up your particular account, click on the a link that they give you, and you will have to add it here for authorization. That's how you connect to Google Colab. If you want to do it on your system, you can also do it on your system. On my system, usually I use Anaconda the download, and I use the Jupyter notebook there. But as soon as I found Google Colab, I've been using Google Colab a lot because it's very easy. I don't have to use too much of my system space, and I don't have to worry about storing in the system. I just store it on my Google Drive. And usually whenever I connect to the drive, I always do a ls command. So whenever this is like Linux, so you can run your Linux commands here, but you'll have to do an exclamation point before that. And you just, I usually do that ls command and see if I'm in the right drive, if I have the right folders. And then I'm actually just storing it on a variable because I just didn't want to keep copying pasting this when I read CSV or CSV or do anything with it. So I just stored it into a variable. So that's what I did to get the data set. It was a CSV, so that was easy. So I just used it there. Okay, now going into the Titanic data set, what we're doing for the data pre-processing, how we're going to visualize it, all of that. Let's get into that. Oh, there's a query. Can you speak a little bit? Oh, I'm so sorry. You're hard to hear, or am I just too fast? I'll slow down a bit, whatever it is. I'll just slow down a bit. Sorry about it. Okay, let me see. Okay, hard to hear. Okay, perfect. Okay, I think my thing was okay. Okay, thank you. So it looks like somebody raised their hand. Okay. Yeah, it asks for the authorization code. Adiola, it is for your account. So if you click on the link that's there given, and it'll ask you which account you want to use, but it's all your account, and it's just asking authorization for your account. So if you go to the link, it'll ask you for the account, the Gmail account, and you can actually copy paste the code that they'll give over there. It's a long code. You just copy paste it into your into the system, and you should have it. Got it? If you have any questions, just go ahead and ask again. Yeah, it'll give an authorization code. Okay, so now going into the Titanic dataset, we have, we usually use NumPy and Pandas. Like if you have been here for the previous webinar session, in the previous session, we spoke about NumPy and Pandas to do all of our linear, number calculations and our Excel calculations, like not Excel, basically our data calculations. So Pandas is usually used when we have to do data frames, series, and all of that. We use Pandas, and NumPy we usually use when we're doing arrays and everything. So if if you were not here for the previous session, if we can go over the collab, we'll explain NumPy and Pandas. Here we'll just go over a little more detail into how we use NumPy and Pandas. And Seaborn and Matplotlib are two of the visualization libraries that we will be going over. Okay, so here what we are doing is we are taking up the data frame. We are reading the data, the CSV file, the trained CSV file here. We're reading it as we are reading the CSV, and we are converting into a data frame. So the Pandas does all of the behind the scenes. So we're converting a data frame and we're putting into df, into a variable df. And here when we do df.shape, it shows us how many rows and columns are there. And this is the data that we have. So when you do df.head, head gives you the top 5 lines or rows, top 5 details of what is there in that CSV file, in a comma separated file. So this is what we have there. This is in the Titanic dataset, we have the passenger ID, survived class, P class, name, sex, age, and all of that. So it just gives us the first 5. So that's what we use df.head for. Actually, we can also do, if you want more, we can do like df.head 10, and it'll give us the first 10 rows. To take a look, we can actually do tail, I think. I've never done that, but we can do df.tail. I'm just running all the files here. And we do, and it will give the last 5 of what's there in the CSV file. Right. So if you see from the shape, you know that there are 895 rows and 12 columns. So all of the 12 columns are there, and our data set shape, the size of a data shape is 891 rows. Right. And here we take so this is a summary of the columns that we have. We have survived, the passenger class, which class they were when they got into Titanic, the name, the sex of the person, age, if they had a sibling or a spouse with them, and if they had a parent or a child with them, that's being calculated. The ticket number, fare, cabin, and embark. So these are the labels that they have come with. So when you go deeper, all these labels and it will be very important, especially when you do machine learning and stuff. These labels will be very important. Now we have all of this information. Now, whenever we are given all of this information, we need to figure out, if there are null values, if there are duplicate values. That's if null, duplicate, like data that we really don't want to be there, we have to figure out if it is there, because we really need a clean data set to work with, right? Without a clean data set, it's difficult to get any information out of the data set. And we use Pandas to basically clean the data set. So that's what the data set pre-processing is all about. So when we do pre-processing, first we need to make sure the data set is clean, and then we visualize the data, try to understand the data before we can figure out what we can do next. So that is what today's webinar is all about, trying to figure out, what are the next steps with the data? How do we get a clean data so that we can predict with the data, right? We also will tell a little story with the data. With this, like, we can tell a story about what kind of people travel on the Titanic, whether they traveled with family, whether they traveled with, how old were they when they travel, how many men travel, how many women travel. So this helps us. With this, we have to be able to tell the story, so that when we go into the next level, as in machine, like in prediction, which we'll use machine learning algorithms for, we will be able to, we'll be able to predict. So that's what we are doing here with exploratory data analysis. The standard data set is actually is widely used. It is because it's a very clean data set. It's one of the most clean data set, and many people have cleaned it so many times, and we have very good data. We only have very few null values and stuff. So that's why we have more database for you to practice, and we just go over what we have of the Titanic data set, and we'll give you data sets to practice, so that you can get you can touch with it. more practice with it more. So how do we handle null values? There are three ways to handle null values. Sumana, Helena, if by any chance you're not able to hear me, please, stop me and tell me, okay? I think it's because of my microphone.
Anju, we have just a request if you can speak a little bit more slowly.
Okay, sure, thank you. Okay, so to handle the null values, there are three ways to handle null values. One is we remove the null values, the NaN rows. The second is to hard code the NaN values to a different code. We use something called a fill NA function. We can like place in, if either we'll go over that. We place in like different values, like what will be mathematically possible. We place in those values. Third is we impute the NaN values based on other rows. So basically, infer what the NaN values will be from other rows. So these are the three ways that we can use the null values, or we can clear out the null values, and we can use those labels or use those rows.
Anju, we're just having in the chat that it's not clear with the audio.
Okay, I think I have to keep holding my microphone top. I don't know what's going on. Sorry about that. Okay. So we'll show you all the three ways here in this in our data set. Here, for the first one, we have to first figure out how many null values are there. So this is what we have done. We have taken the row. df.columns actually just gives the columns in the data set. So if you do df.columns, it gives you how many columns are in the data set. So we take from the df.columns, in Pandas data frames, you can actually do manipulations within the Pandas data frame. That's what is happening here. We take the df.columns, and within the bracket, we take the data frame. We find out which are the null values, which columns have null values, and we apply the function any. Any is a function in Python, or also in Pandas, that returns true if that particular function is true. So basically what it says is that for the data frame, if it is null, it's applied to all of the rows, with all the rows and the columns, whichever columns have the null value is taken, and then this outputs the columns that have null values. The columns with missing values, this outputs the null values. Here also what I've done is I have printed out data frames that have null values. So as we see here, the columns that have missing values are the age, cabin, and embarked columns. And here, if you see, this gives a sum of all the NaN value, or all the null values, or the NaN values. So here, if you see the age column, we have 177 null values. So 177 people have been given their age. And here, the cabin has we don't know the cabin of 687 people, and embarked has only 2. Okay. So this is how we get all of the null values. These are all the null values that we have. So what does any do? Somebody has asked, what does any do? Please ask your questions in the Q&A. That will be helpful. Harini, so Harini has asked, what does .any do? So basically, .any is a function that is applied to any. It's applied to anything that's been given to it. So here, if it is given for the data frame, if there is a null value, right? So basically, any applies it to all of the functions. Right? It applies it to all of the functions. It goes through every row and figures out, okay, it's null, will apply true or false to it, and it applies true or false to it. The function that just applies true or false to it. Hopefully it answers your question. It'll not print it. So let's do that. Let's take out .toList and try. Let me. Wait, somebody asked a question. So Tiffany, let's just try that. Let's take out .toList and see what's going to happen. It's not going to it's not going to give it as a list. That's the main thing. It doesn't throw an error, but it doesn't give you the list. So you have to like list it out. Okay, so here we are actually also doing the count in a different way. I usually try to do it this way. This is like a better way of presenting it. So this is how we figure out how many have the missing value count. Okay, and we find the missing value count for all of, we find out like how many rows are there, ages, how many null values. Here we know that age, cabin, and embarked have missing values because we found out which columns have missing values, right? So that's why we're able to figure out which ones have missing values. That's another way of doing it. So now that we figured out which rows, which columns have missing values, let's go to figure out how we are going to solve that issue. Because when we have null values, it's difficult to work with null values. So we need to make sure that either we clean it out or we impute values into the null value, or fill the row with something else. Usually like account number or something, we cannot fill it up. We may have to like account number usually is a unique number, so we can find the next value from the previous value and fill it up. But sometimes like price, if there is no price, we may have to just add in a 0, so we'll just fill it as zeros or something like that. That's the same thing. Having null values is it's not really good for the day for the rest of the stuff that we have to do. So here we go. So with the embark, since there are only 2 null rows, what we are going to do is we're going to drop it. We're just going to drop it. Since it's not going to make much of a difference, right? By dropping just 2 rows. Actually, it depends on the size of a data set. I have worked on data sets that have been a very large size, and I have just dropped those null values and worked with a smaller data set. So it depends on the data set. So it's not like only if you have 2 rows or 3 rows, like if you have a small number, you need to drop it. It just means like when you look at the data set and when you try to figure out if that number makes a difference or not, that's how you have to figure out. So if it's a huge number, if a particular column and a huge number, maybe 50% of the data set, the column is not filled, and if you delete all of that, you're not going to be able to use that data set, right? So depending on how big your data set is and depending on how, how many null values you have, you can either drop it or try to figure out whether you can what is that, you can infer details into that column. So here we are going to drop it. So this is where we are dropping it. Basically what we're doing is a one-line function in Python. From the data set, from the df data frames, so data frames that we have, all the so this is tilde sign is a null value. It's like not value. So not if embarked. Okay, so if that embarked has is NA value. If it doesn't have NA value, keep the data set, keep the data frame, or keep the row. If it does have null value, then drop it. Right? That's what this line is saying. So go over all of the rows of the particular data of the data frame, which is df, and if it doesn't have for the column embarked, if it doesn't have null, then keep it. If it has null, delete it. So after deleting it, if you see, you have the number of rows which has reduced in size, which is basically by -2. by -2 is reduced in size after dropping. That's what we are doing here. Now, that is how you can drop, or you can also use the function drop NA. It will drop all of the NA. So here, since here we are going through a particular column, which is embarked, and trying to drop just the null values in that particular column, that's why we are doing this method. There's also another function called drop NA function, which will completely drop all of the null values in your data set or in your data frames. It's called a drop NA. You just do data frame.drop NA and we'll just drop all the values which are null. But here we are doing it only because embarked, we are only going through an embarked column, and the other two columns, null values, we still want to do something with it. Okay. If you have any questions, please ask. Q&A, we have 2 questions. No, so Tiffany, isNA is not used to delete null values. It is to find out if it is a null value. If it is a null value, that's what isNA is. isNA function tries to find out if it's a null value. I'm so sorry, I'm going to kill your name. Could you write the command to drop? Yes, I can do that. But I don't want to drop the values. I'm just going to like write the code. Maybe, let me see. df.drop NA. I'm not going to run the field because I do not want to drop all the values now. So actually should do df is equal to df.drop NA. Then it will reflect on the data frame. So in Jupyter, there's one thing you can do is you can figure out what happens when you write a particular command. So if I just do df.drop NA, actually it won't drop it until I okay, I don't want to do that, but usually when you do that, it'll just drop everything and show you what is dropped. But when you actually assign it to a particular data frame, like if you assign it back to the data frame, it will drop. So here, I have dropped the data frame into a different variable, and I will do dot is null. Here, if you see, there are no null values. I just assigned it to a different variable because I didn't want to change df. So when you do df is equal to df.drop NA, it will go back to the df variable, and it will reflect on the actual df variable that you're working on, which the df variable is what we read the read CSV into. So we read the CSV into that df variable. So basically we read the CSV, converted into a data frame, which actually Pandas did. Pandas converted it into a data frame, and we assigned it to a df variable. Here, what I just did was I assigned a df.drop NA to a different variable because I did not want to change the df variable itself. Hope you got the drop NA here. And this just drops all of your null values. And if you see the data frame dot shape, let me just take the shape and show you. So, you know, we have lost a lot of values, right? It's dropped from 891, it has dropped to 889. So that's what has happened here. Now that, okay, if you have any questions, please go ahead and ask in Q&A. Hopefully you got this information. Conception, I think. Sorry if I killed it, I'm very sorry about that. Hopefully you got that drop NA. Now moving on to what we're going to do with the cabin column. Okay, perfect. Moving on to what we got with the cabin value. So cabin had 177 177 rows, right? A total number of 177 rows did not have cabin values, so they were null. What we're going to do is we are going to impute the value by filling it with the most frequent cabins. So first we find out which are the most frequent cabins, with value count. So value count is a function in Pandas that takes the count of the count of all of the unique values, right? It just takes a count of all of the unique values. So if you do df cabin dot value underscore, it just gives you all of the cabins, the count of all of the cabins. So how many cabins are there, just like for particular B96 and B97, how many cabins are there? That's what it gives. And from there we are taking the maximum, because we want to find the most frequent cabin. We take the maximum of the cabin values, and then we fill it up. Here we find out the length of the how many cabins with is NA, and then we fill it up here with that most frequent cabin, that the most frequent cabin number counts with cabin we had. So here we get the most frequent cabin, and here we're filling up all of the 177 with the most frequent cabin, and we don't lose, and we skip on the null value. So that's what we're doing here. And then if you see after, we have no NA count, we have no null count after filling it up. Okay, so that's what we're doing. That's how we are filling NAs. NAs is null values. So that's how we are filling. So we're taking the most frequent cabin, and we're filling up the ones that we're in the cabin column. We are finding that from the in cabin column, whichever has is null values, and we are filling it up with the most frequent values, most frequent cabin values. That is what we're doing. That's the second one that we did. Now for the third one. Now in the third one, we are going with the age. So since age is a numerical number and not categorical number, we'll come to what categorical and numerical numbers are in a few minutes here. So I have also added a link to where you can get more information on fill NA details. You can go to this link and you can get more information on fill NA. So for the age, we are just going to take the mean of age of the passengers of the ship. And when you're doing all of this calculation, the real world data, make sure none of the things that you do affects the way your data is. So sometimes taking the mean of age will be good. Like here, mean age is fine. But somewhere you can't take some other data set, you can't just take the mean. So you should be aware of it, and you should make sure that if you're doing if you're imputing, or if you're doing any mathematical calculation, it's a valid calculation that you're doing. These are just side notes that I have learned when I was doing real world projects, so I just wanted to share that. So we're taking the mean of all the passengers on the ship. Now with this, so there is in data, there's a mean function in Pandas. So from that, we are going to use that mean function, for the mean function for the age column in data for the particular in the data frame or data set. We're taking the mean age, and then we're printing out the mean age here, and then we do the same thing like we did before. We find out how many SNA are there. Then we are going to fill all of the SNA columns in the SNA rows in the age column. We're going to fill out all of the is null, so basically null values in the age column with the mean age, and we check after that we have SNA. Oh, I think I said 177 cabin values, but age had 177 cabin values. I think it was a little more. Cabin was 687. My fault. Okay, we have one question. for cabin column, why aren't we filling the NA values? Because cabin is a categorical value. Like it's not a cat. It's like it's numbers. Yeah, it's categorical because it's numbers. It's like G28, B29. So we can't take the mean in that because it's not a numerical value. Only the numerical values can we take mean. So that's why we did not take mean for cabin values because it's not a numerical value. Yeah, that's why we are using most frequent values. Hopefully you got an Harini. So why when you're dealing with numerical value, which one will be preferred? When you're using numerical values, usually statisticians say median is preferred because median gives a better average than mean. But sometimes we'll use mean. Usually we use mean, but it depends on the data set. So here we have ended up using mean, but you can also use median. Harini, that's for you. Susie question. Okay, Dawn asked a question. Okay, perfect. Dawn asked a question, does it matter if we round age or a similar numerical value in this type of example, or maybe it's not? No, it's fine, Dawn. Like you can round it. You don't have to round it. Here we did not round it, but you can. Usually age must be a round age. So you can. That's why I mentioned previously, there's a possibility that, you may choose to do differently, and that's fine. Here we did not round it. We just showcasing it to you. We did not round it, but if you want to round it, yeah, you can round it. I think rounding in age is a good idea. Okay. Okay. Hopefully that answered your question, Dawn. If you have any more questions, you can ask in the Q&A session. Okay. So now we have filled all the null values. Now we have if you see, we'll have a better data set, better data set. It's a clean data set. So let's go and figure out what else we can do with that particular data set, right? We'll do some descriptive statistics on the data set. So descriptive statistics is actually a branch of statistics that gives the spread of the data. Like it gives the mean, median, all our mean, median, standard deviation, variance. All of this comes under descriptive statistics. This inferential statistics is more based on like mathematical calculations behind the data. That comes under inferential statistics, like hypothesis testing and all of that comes under inferential statistics. Udacity does have 2 courses which are free, by the way. Which are really good for understanding descriptive statistics and inferential statistics. You can take a look at them. Understanding statistics is very, very important. It's kind of, it is kind of important because in all my real world projects, I've always come across the fact that statistics has played a major role in understanding the data. Before we even going into prediction, it's been very helpful. So understanding statistics is understanding the statistics of the data that you're working on is very important. Not just the mean mode also is very important because when you're doing like machine learning activations and algorithms, all of this, like where does the mean fall, where does your median fall, all of this are important with your whether the data is normal distribution or not becomes very important. Whether your data is descriptive or discrete or continuous or all that gets very important. So getting little bit of knowledge, and I like the Udacity course because it's a free course and it gives you a good depth for the statistics. So if you can take a look at it, it'll be very helpful. That's all. So let's go into the statistics of it. Here, I actually also wanted to point out one note that I learned personally from my projects is that whenever you are looking at real world data, it's always best to go into and figure out what the D type of the data is, because here we had a pretty good data with the Titanic data set, right? Everything was integers were integers, floats were floats, what we needed, like ticket number was an object because the string was an object. So we had this, it's basically a clean data set. But sometimes in the real world, so when you work on different projects, that may not be the case. You may have to change the data type of the particular particular column. To do that, as type, you can change that particular column by using dot as type and change the particular column. You can check out the documentation here. That will be very, that helps you change the values of the function to, like if you want to change int to float or int to string, that will help. Okay, so with df.info, we get all of the info of the rows and the columns. Here, we get the information of that. So here, if you see, now we'll get into the numerical categorical type of data. If you see, all the columns here are numerical. Most of the columns here are numerical in nature. The int64 columns indicated that it might be a categorical column. So some of it is categorical column, and some of it are numerical columns. Like age is a numerical column, but like survived or your sex is a categorical column because it is qualitative, not quantitative. So what all this means, I will just go into that. Now here, understanding the data is very important. So the data comes in different types. Like there's categorical data, there is categorical nominal data, or there's numerical data. So categorical data defines like for example, a sex, right? Male or female. It categorizes you based on what you are, right? Whether I'm male, female, or other. So it categorizes it. It's a quality. It figures out that data figures out the quality. So that's why it's categorical in nature. And there is numerical values, which is like age. Age is a numerical value. Price is a numerical value. And in the numerical values, there is also discrete data and continuous data. So if you see here, I have, so it's important to recognize the different types of data that you're working with. So there's numerical data, categorical data, and ordinal data. Numerical data has two sub, which is like discrete and continuous. Numerical data is broken down into two, which is discrete and continuous. And actually ordinal, I have not written much about it here because ordinal is actually a mix of both numerical and categorical. That's what ordinal is. So most data types fall into numerical or categorical. Okay, and numerical data is further broken down into discrete and continuous. This is a good link where I understood more about the statistical, numerical, categorical data. So we have a question. Okay, so Sobrania has asked, the value of the output of the analysis depends on these numerous decisions you make throughout the analysis. Do I replace NAs with mean or mode? Do I round the age? How do you get better at these decisions? Does that come only with experience? And how do you check if the decisions you have made are good? That's a wonderful question, Suganya. Yes. So in my experience, I can talk to you from my experience. In my experience, actually, it did take a little bit of working through different types of data and different types of data and different ways to get data to figure out if whether I should fill the NAs or drop the NAs. And also if you're working with a group, you also can get more inputs with the group, with the team. Sometimes when you're working with the customer may not want to delete all of the null values, right? And they may want to do something with the null values. For example, like recently I worked on a project for a banking project, and there they actually wanted us to fill null values with a particular formula. Right? Because it was banking and they had a different formula that they wanted us to use, and we had to use that and fill the null values for some particular column. So it depends. One comes through experience. Two, you talk to a few people if you're working with few people, or if you're working for a customer, you ask the customer, is it okay? Hello, can you still hear me?
Yes, we can hear you.
Okay, thank you. Suddenly I had a disconnect, so that's okay. So you ask the customer if it's okay or if you're working on a project, you ask the person that you're working for if it is okay to delete the null values. or you discuss with the team and figure out if there's better ways to fill the null values, right? So it depends on the environment you're working with. If you're working on your own project, then you can do what you want, right? And if it doesn't matter. But if you're working for a customer or if you're working for a different project, you need to figure that out, what you need to fill the null values with. And how do you check if your decisions made are correct? Even before going into the prediction, you can figure out your decisions. By when you visualize the data. When you visualize the data, you'll figure out if what decisions you made is good or not, because you may not find too many outliers. Right? Outliers are something that goes far away from your. It lies away from your general values. So. So that's I have found it through visualization. Somebody can point, but it's usually through visualization you find out. Did you get that, Suganya? Hopefully you did. Okay, perfect. Thank you. Okay, so now here I just put in a chart to compare your discrete data and continuous data. Why I'm focusing on data is because this is actually important, which many online courses don't show, which I felt like many. So when I was going through online courses or when I go into other courses, I did not feel that they're giving much importance to like the data and understanding the data before going into modeling and prediction, all of that. Every time we talk about machine learning, it's always about let's predict, let's use which algorithms do we use and all of that. But many of us forget as machine learning engineers that we have to look at the data. We have to first think like a data analyst before we go into the machine learning perspective. Most of the time we have to spend on the data. So we need to understand data. We need to think like a statistician first. I think our biggest win will be if you can think like a statistician and a programmer, which is very difficult, but if you can think like both, that's really your biggest win as a data scientist or a machine learning engineer. That's what I have understood from my experience. So that's why I'm concentrating a little more on data and trying to get all my points across. If if you have any questions, let me know. Or okay, so Dawn has asked, so if you have many outliers or something seems very off or weird, does it mean you may have made wrong choices in it? Yes, absolutely. If you have too many outliers, you may want to go and look at your data again. That's where the data analysis becomes very important. When you have too many outliers, and because once you move the state and go inside, you're going to figure out that all the outliers cause you a lot of issues with the accuracy and your R2 scores and everything, when you go into that space. So if you see a lot of outliers, take a look at the data again. Try to figure out if there's any other better way to do some feature engineering, or try to get normalized data. Sometimes you may figure out that a particular data that you have may not give a prediction based on these outliers also. It'll tell you whether or not these outliers are important. So so like how Sumana said, it also means your data is of bad quality. So finding out that early when you do any data analysis is very important. Okay, so here I have the another question. Catherine, okay. I'm confused by mutually inclusive for days of the week in the chart you are showing. Okay, how can days of the week mutually inclusive? No, actually, so this classification is a very broad classification that they have shown over here. Days of the week, they're actually giving it as an example of discrete data. Like it's not continuous data. It doesn't go as a range. That's why they're giving you the example of days of the week. They're not the mutually exclusive part only when you're doing the. It's actually a broad classification that they've used here. Even I found an issue with that, but it's actually a broad classification. The days of the week, the example that they're given is only for discrete data. What kind of data is discrete? Days of the week is a discrete data. Got it? Hopefully. Okay. If you have any more questions, Catherine, you can ask in the Q&A. Hopefully you could understand that. So, the classification that they've said is, this is it's a broad intro to that. So that's why they have mutually inclusive. Okay. So I just did a note that understanding continuous discrete is very important, because when you're choosing machine learning algorithms, you may have to choose it based on what type of data you have. Some algorithms or some activation functions will go better with discrete data, and some will go better with continuous data. Okay. Okay, now we come to the next. We're just trying to find the unique value here. Unique value for all of the how many unique values are there for all of our columns. Here we're running the function unique on on all of the columns on every row to figure out which, so passenger ID, all of the 889 will be unique because they are the unique number. And survived, as actually this shows you which ones are categorical and which ones are numerical, because here she does show that survived 2 and P class are categorical because there are only 3 different classes that are there in the Titanic, which is first class, second class, and the third class. And survived is either 0 or 1. So those are categorical values. You either survived or you did not survive. And age is not a discrete value. Sex is a categorical value here. Yeah, and embarked also is like 3. I think only 3 is there on embarked. I don't remember on 3. Okay, and now we are getting the statistical distribution with describe. So Pandas has a beautiful function called describe, which gives you all of the statistics on the data set that you have. So it gives you the count, the mean, the standard deviation, the min, the max, the quarter percentile, the half, and the 75%, all of the information. So with describe function, you get all of the information for the particular data set. That's what we have here. Now, going into, like, we can get the histogram of this data set, of this the statistical distribution with the histogram. So here it says like how many people are of the age 50, there's only so much, but here I think in between 0 and 50, 25. So it looks like there are a lot of youngsters in the particular in Titanic. These histograms visualize that. So here we are actually using inbuilt matplotlib. We're using matplotlib for visualization, and we are visualizing that using matplotlib. So this is for the age, this is for the fare, the parent, children, the passenger ID. Passenger ID will have to drop. You won't need much, I think, to help. If you see in the next part, if you're using the same Titanic data set for the machine learning algorithm, we'll just drop passenger ID because it may not be very useful to us. And okay, when you come to here to the P class, you can clearly see which ones are categorical and which ones are numerical data. If you see here, there is a flow. So it's numerical. Here if you see they are categorical values. It's like either they are in 1, they are in 2, or they're in 3. We have questions here. Okay, so Abriel asks, would it be better to look at a histogram of age before filling the nulls to get a better sense of the known distribution? Yes, you can do that. You can actually visualize it before and figure out which is the mean, which is the value that you want, and you can figure it out. So yes, you can do that. That's a good idea too. But also when you get the mean, you do get the mean, right? This will give you the mean, but also dot mean will give you the mean. But so you can. Okay. So from here, you'll see that P class, survived, embark, and sex, they are our categorical values because P class has only 3 classes, survived has 0 or 1, either they survived or not. Embarked has only 3 values. I think there's P, C, S, and C, I think something like that. And sex has 2, male or female. Now here we have coming to Seaborn, and Seaborn is actually my favorite is Seaborn. I don't know why, because it actually gives you very, very beautiful visualizations. Seaborn gives you very beautiful visualizations. So you can look at, and they also have a very good tutorial. So if you take a look at the Seaborn PyData.org, it has a very good tutorial. Here we are doing a pair plot. So we are doing a pairwise relationship in the data set. Here, if you see, we are like, so basically, if you just do like SNS pair plot for the DF, it itself, the Seaborn itself, will calculate everything and it'll print out to you. See how it's very beautiful. That's what I like it so much about Seaborn, is because you just have to you're just giving it the whole data set, the whole data frame, the data set, and it just pair plots everything to each other. So here it takes in all of the survived here, and if you go down below, it'll show you which ones they are against, right? So I'll just show you the ones at the bottom. This is against fare and passenger ID. So which passengers pay the lowest? Like, it looks like only a very few people have paid the highest amount. And this is between survived and fare. So actually, if you see very clearly how this is a categorical value, because either they survived or not survived, and then the fares they paid. Looks like the one person who survived paid the most, the top level. So here the different classes, like 1, 2, or 3 classes, and the fare that they paid for that. So this is how the pair plot shows. So it just pairs up and does the calculations behind the screen and gives you all of it, right? So if you ever choose to drop certain columns and even try, you will get different values. This is very good before you go into prediction, because it tells you which ones will give you signal or which ones will give you a prediction before you go into the next phase. So that's why I said data analysis is very important, because all of this tells you if your data is good, if your data is worth the effort that you're going to put into it, or should you. So this tells you basically whether you have to put effort into your data or if you have to put effort into your algorithm. That's decisions you make here at the EDA part of it, which is exploratory data analysis part of it. You make the decision which side you want to go. Sometimes you may be stuck at finding data for a long time. Sometimes you have good data and you move on to the next step. Now, here we are coming to correlations. Okay, we have a question. Harini has asked, how does pair plot and visualization help us eliminate columns that would not be useful for predictions? Okay, that's a great question. I'll tell you from my personal, I'm going to tell you from a personal example, because this is like, I don't know what else. From a personal example, actually, I found out that during visualization, when you're visualizing the data, so for example, so you can figure out what algorithms you want to use. 1, 2 is like if for example, fare and survive, they have very categorical columns, right? So sometimes if you're missing certain columns, you can't do much. Just with survived and fare, you think you can do much with the data? No, we can't do much with the data. We only have the fare that the person paid. Okay, for example, passenger ID. You have passenger ID, fare, and survived is your original data set. Just for a second, let's think about it that way. You only have these 3. Okay, so you pair plot it. You pair plot the fare, passenger ID, fare, and survived. You figure out that it's like a very categorical value. There's no way for us to get there's a reading out of it, right? So that time you can deem that particular data set as not useful to us. From here itself, you just have fare and survived. You figure out, okay, first survived is a target variable. For example, P class. Let's take, for example, P class. We have fare, P class, and passenger ID. So how do you know which particular passenger survived? There's no way to know that, right? Sometimes you do get data like that. Sometimes when you're working on some projects, you may end up getting data like you don't have all of the complete data for a particular information. Like, for example, recently I worked, again, I'm bringing up my banking because I just finished the project. On my banking data set, we had data like this, where we had like few columns. We did not have whether the particular person got credit or not. right? So when you get that kind of information, you have to either get dummy values, or tell the customer, or go and get more data on that. So if that's that's how what this particular visualization step will tell you, that whether you can proceed forward with a particular data set, or you have to go and get more data set. Did you get that, Harini? Okay, no. Okay. Okay, now moving on to correlations. So correlation is actually a statistical technique that tells us whether how strongly connected the particular pairs are, right? How what is your correlation coefficient that you get for particular for all of the pairs from this. We are using all of the columns from the particular data set is because to predict for the particular data set, we need all of these columns, right? So from this column, you can say, okay, these two columns are correlated, with which we can actually get prediction, with which we can use to get our target, reach our target value. That's why we use this correlation. There are two references that we have shared. The YouTube video actually tells you how correlations are calculated, which is a good video. You can understand how these correlations are calculated. So basically, they tell you take the mean of the particular value and then add sum it, square it, and divide it. So that's these two are good references to go over for correlations. It is important to understand correlations. So sometimes from the correlations, you may get very low coefficient values. From this, you can figure out whether you will get any predictions out of this particular data set, right? So you are trying to analyze the data set that you currently have. So from this, you can figure out that P-class and FAIR, age and parent-child, age and sibling, all of this have correlations. So we can use this to get our predictions, right? So if you were from a particular P-class, it looks like you survived more than from the, so depending on the class that you were in, it looks like you may have survived, right? And depending on if you have a sibling or a spouse or a parent or a child, how you survived, that correlations will help us. The strongest correlation is 1. So Pranjal asked the question, how much correlation is a strong correlation? That is, the value of correlation is taken as strong correlation, as are there any rule of thumb? So 0 is the lowest and 1 is the highest, and whatever we have in between the numbers, you actually depends on the particular data set that you have. So on the particular data set that you have. So if you have, like, for example, like if you have 0.07 or minus 0.07, those are all actually like low correlations, which may not, which may not help much. So there's no rule of thumb per se. It depends on your on the data that you have. Hope you got that. Franz, you can ask questions further if you have any questions. Okay, correlation and causation. Correlation is the statistical measure for to find the relation between two variables, or between two variables. Causation basically is casual interference. Another question. Catherine has asked a question. In this case, we're looking for numbers closest to 1 or -1, positive or negative correlation. We actually were looking for numbers in the negative, closer to -1 here. Closer to -1 gave us better correlations. Okay. That's what we did here. Okay, Nakoya is after Python, what should be the next platform, and so on at next 3? Wait, I didn't get a question. After Python, what should be the next platform, and so on at least next 3? Do you mean like which platforms do you need to use after Python for? Okay, so you can use R. R is good. I don't know if you're asking to learn or what do we do in a particular machine learning pipeline. What do we to learn? Okay, to learn you can you learn R, but it's not very necessary. Okay, Sumana is asking. You can learn R. Okay, now we also have for the particular if you go into machine learning, we can learn PyTorch, Keras, TensorFlow, all of this. But that's in the machine learning algorithm. If you're looking at data analysis, it's mostly use R and Python. Currently, these two have very good libraries to help you with all of this that we are talking about. The statistics, R is very good for statistics. Would you say R is easier and less complicated than Python? I like Python more. I think it's a personal preference, Tiffany. In personal preference, I like Python more. Some statisticians will like R more. Some people like R more, but I like Python more because I can just move into machine learning algorithms smoothly. Once I do a lot of PyTorch, so for me moving from this to PyTorch was easy. So I just so it's basically comes as a personal preference. But you can try both, and whichever one you like, you can choose. I always prefer Python over R. That's personal preference. So Nakoy has asked for data science. So yeah, for data science, so the data science machine learning pipeline is such that first you do some data cleaning, data preparation, and then data preparation, data visualization, and then you move into modeling and prediction. That is the data science pipeline. So when you are looking at the data science pipeline, for the EDA portion of it, Python and R have very good libraries. I have not heard of any other language yet that has good libraries, or worked on any other language that has good libraries. Once you're done this and you go into machine learning algorithms, that is when you machine learning has like scikit-learn, which is also Python based algorithm. So it's Python based. And then if you I think everything that we have is Python based. So if you're looking to learn something, Python is the best, I think, currently. But I read somewhere that Python will die one day and you should not be completely focused on Python. But currently for data science, Python or R are the languages. Also, when you're moving into cloud, like if you are, once you're finished prediction and all that, you will have to deploy your model, right? So when you're deploying a model, you need C++ there. You need to understand, but there is a library in PyTorch or in any of your machine learning algorithm libraries. There is the library that will connect you to C++. But if you want to be on the deployment side, if you're deploying it to the cloud, you need to understand C++. Currently, C++ is what they're using. Okay, thank you, Naka. Okay. Elizabeth has asked a question. So glad to hear you say this. I was thinking about learning Python, R, and JavaScript because of Hadoop and MapReduce. Please correct me if I'm wrong. Yes, Python, R, JavaScript. So actually, even for JavaScript, so like actually, if you see the machine learning pipeline, the whole flow. You have front end, and for your front end, currently some of them are using Flask, or your front end algorithms like React and all of that create a Flask has currently been the best transfer between your front end and your machine learning algorithm, your model training, model prediction. So you need to know your front end with JavaScript, HTML, CSS, and then your data manipulation, data prediction, and then your end cloud is C++. So if there's anybody looking for this whole thing, we're all dead. But the whole thing requires, your front end requires some Flask, HTML, CSS, and your middle needs Python, R to do your data manipulation, your machine learning algorithms. And when you're deploying it, you need your C++. You definitely need C++. It's currently, even though Python has a library to actually deploy it, you need the C++. Suganya has asked question, pardon me if this question is too broad for the session. What exactly is the link between DS and ML? The boundaries seem a bit blurry to me. There is no way to like, so data science is a science of data, right? So data science includes all of this, like all of the statistics, the data statistics, all of it, machine learning algorithms. It's the whole scenario here, right? All of what we are doing falls under data science, you can see, because you're manipulating data, you're working with data. Machine learning is a set of algorithms. Currently, it was the first set of algorithms that came out, which uses the certain algorithms. So like for supervised learning, unsupervised learning. So it takes a certain length of algorithms for machine learning. So machine learning is a part of data science. Then after machines come deep learning, which is also part of data science, you can say. This all falls under artificial intelligence. So you can't draw a line and say, okay, this is data science. Right? Like even if you look out for data scientist roles, certain companies will ask you to know machine learning algorithms, or certain companies will ask you to know neural networks, computer vision, all of this, you know, they may ask you as a data scientist. So that's not a very clear cut definition between, oh, this is, you're a data scientist if you know this, and you're an ML engineer if you know that. No, if you're an ML engineer or a data science, you got to know all of it. At least with the ML engineers, if you know your scikit-learn libraries, like your supervised learning, all of that is good. But if you're a computer vision person, you need to know the computer vision libraries, like neural networks, convolutional neural networks, and recurrent neural networks, all of that. So it's huge and it's broad. Hopefully that answers. Yeah, the link is between data science and ML. ML is part of data science. It's a science of data. All done. Okay. Questions are all done. Thank you for your questions. I think we'll go through the rest of it fast, and we'll complete. I think we should finish by 1:30, right? Okay. Sorry if it's taking too long. So causation is basically causal interference. It's an event occurs because of another event. So the cause and effect. The cause of a particular event is because of another event, right? That is causation. I just remember I'm not done. Now let's go into some feature engineering. With data analysis comes a lot of feature engineering too. When you say feature engineering, is we add more values from the features that we have already, which is the labels that we have. From the labels or the features that we already have, we come up with new features, right? For example, here we are counting the number of relatives for a particular passenger. Right? So here we are adding a new column. So to add a new column in a data frame, you can just choose a new column and just write it there. Like we can just like how you call a column, which is df box brackets and the value. You just create a new value, and then you add for if they have siblings, you add the sibling spouse, the parent child, and you know this gives you the df. Like if you now see df.head, you should have relative count there. Yeah, see, you'll have relative count here. So you're counting the relatives. Then and here we are visualizing the relative counts. Whether somebody brought like between 9 to 10 relatives. And then we can figure out if a particular passenger was traveling around. np.where is actually a function that returns x or y depending on the condition. So it returns yes or no depending on the condition. From there, we're figuring out if they came with a sibling or a parent, sibling, spouse, or parent, a child, and we are right here. We have said whether they're coming with traveling alone or not. So some people were traveling alone, some people were not traveling alone. So here I've had value counts. 535 people were traveling alone and 354 were not traveling alone. And we're visualizing that with a pie chart. here we are visualizing with a pie chart. Here, this is the same thing. So we take for the travel, we are choosing only the travel alone column. We are getting the value counts over there, and we are plotting it in a pie plot. So this is a matplotlib inbuilt function that we're using. The data, the plot inbuilt function, the Pandas plot inbuilt function. We're just plotting it there, and we're using the kind is what type of plot that we want. We're using which we are choosing pi. The title we had chosen as travel alone distribution. That's the title. We have a legend here, and this is to align it, align the label and the pi. Okay, then we are trying to bucket the age to figure out which how many fall under a particular age. This is what we have done. We have tried to figure out how many are less than 15, between 15, 30, 30, 30, 45, 45, 60, or greater than 60. And we are applying that bucket age to everybody, to all the rows in the particular column age, to all the rows in the age. We have a question from Elizabeth Jean. Will the PM tell us what programs to use, or is it up to us as long as we deliver? I ask because I've taken classes which choose to use Orange or Nime, and it gets confusing after a while. So actually it depends. Yeah, it depends actually on the PM. Sometimes they tell you to do what you want, but sometimes they request you, they ask you to use a particular framework or particular flavor of it. So yeah, it actually depends. Depends on, if you're starting out, you can choose, but some companies will already have what they want and they'll ask us to do that. So that's a very dependent on the project, on the PM. Hopefully that answered your question. Okay, thank you. I think PM, when she said PM, she meant project manager, right, Marijuana? Like, yeah, project manager or product manager. Okay, now we are doing some visualization. We are just, here we are plotting the P class in the value counts, because we found out that P class is a categorical value, right? So having it in a pie chart will be good to understand, to see how many fall under category 1, 2, and 3. Okay, but okay, first time seeing this in Python. Okay, thank you, Don. And then here, okay, group by function is a very beautiful function. It's a very important function to group by and try to understand the values. So here what we're trying to do is we are doing a group by on P class and survived, right? We are grouping the P class, and we are grouping the survived and taking the size of it. We are unstacking it and plotting it here. So we are trying to figure out from the P class how many survived, how many did not survive. Okay, that's what we are doing here, trying to figure out like how many in the P class. We're visualizing how many survived, not climbed, based on the P class. Okay, does P class and sex. So sometimes, so you got to ask these questions when you are looking through the data. You ask these questions, right? To understand the data better. These are some of the questions you ask. Does the P class and sex relate in any way? So if you were a particular sex or from a particular P class, what are your chances of surviving on the Titanic? So that's what we're doing here, trying to understand the data better from the P class and sex. We are trying to figure out, based on the sex, how many were there, how many passengers were there, and based on that we're trying to figure out whether they survived or not. Unstack, I'll come to that. I will show you what unstack does. I remember adding that because I like that function a lot. So where did I do that? Okay, I have no idea where it went, but let me show that to you. Let me show what unstack does. So when you actually take the size here, right? When you take the size here and when you run it, you're getting it like stacked. You see that? You get the P class for particular P class 1, survived 0, 1, and you're getting the counts here. You see that? It's like stacked. They're stacking it. Now, when you do the unstack, it categorically separates it like this. So for this particular function to run, it's good if you unstack it, because you are trying to plot it. You're trying to unstack it and you're plotting it. So that's what you're doing here. You're plotting it here from unstack. That's a good question, actually. When I was working on it first time, I didn't understand stack, unstack, and yeah. Hope that answered your question. Hope that answered your question, Gloria. Let me know. And Harini has asked another question. How does group by make us understand the data better than pair plot? Group by is just a different way of understanding data. So here with group by, you're actually grouping it according to a particular column, right? Particular columns also. It can be particular columns. But so basically, you're trying to group particular columns and understanding it. Pair plot, you're just pairing it for the particular. They're just different ways of trying to understand the data. Sometimes pair plot may just be enough to understand the data. Sometimes you have to group by particular. So in this, we're doing group by because we want to figure out, we're grouping the P class and survived, grouping them together and trying to find out if how many survived from the particular P class, right? That's what we're trying to plot here. So, so there are two different ways of understanding the data. Now we are doing the density plots. The density plots are like a kernel density plots is basically does a probability density estimate. There's a reference here to go over what KDE plots are. It just gives you a smooth go over of the distribution of data, right? So whether it's a normal distribution of data or not, you can understand based on this, the KDE plots. Here we've done that. Here we have done a fair and survival KDE plot. This I'm going through fast because most of it is just trying to understand the data in different visualization functions. We have like box plot here. So how does a box plot in Seaborn separated? And this is what gives you the, so if it is outside these lines, they're outliers. This is within the interquartile range between Q1, Q2, and Q3, the median, the minimum value, and the Q3 value, the Q1 value, and the minimum value and the maximum value, which falls within Q1 and Q3. So this is your description is in this box plot. The description. You have references for the box plots here, and we are showing you a categorical plot between the fair and the sex here. This is the categorical plot for Seaborn. This is the categorical plot for between the P class and the age here, right? And then here we have the categorical plot for age bucket and fair. Okay, so so this is what we did with the Titanic data set. We wanted to show you line graph and also like let you work on the database on another data set. So we have the crime-based data set from Kaggle here. And with this, we are actually able to, you can do a lot more on this, but we wanted to use this to show you a line plot. Here we are doing group by on here. We are doing group, so in this here we are doing a group by on here, and we are taking the incident numbers. Okay, we are selecting after grouping by here, we are selecting the incident numbers. Okay, because we are taking the incident numbers to count the incidents, the number of crimes. So we are plotting the number of crimes to year. So we are grouping by year, and we are taking the incident numbers because we want to do the count on the incident numbers, and we are plotting it. Got it? Hopefully. That's what we're doing here in this group by. We're using this to showcase the line graph. You can also use this to do some cleaning if you would like. And here we're doing another one, cumulative month-wise. We are grouping by month. We're counting the incidents per month, a number of incidents that has occurred. And we are trying to plot that per month, how many incidents occurred in Boston. Looks like June, July, August, September, it goes low. So it looks like June, July, August is bad month in Boston. Okay, so I just done a group by for the size here, and then I did the unstack here to show the unstack the function better. And here. So when you unstack and you paint it, this is for the, we are doing on month and day of the week. So we are trying to figure out for the month and the day of the week, we are grouping by them to understand how many crimes happen, the incidents of crimes that have happened for per month and per day of the week. Does it mean Sundays have higher or lower? Looks like Wednesdays have the highest. Month 8, Wednesdays have the highest. Okay, now so this is the webinar all about. Now it's your turn to go over to do some EDA, some data analysis. I have shared with you like a GitHub, and this is the Google, the IPAYNY file, the Python library file to go over. This is another property data analysis of NY. You can go over this, the questions you need to ask, how a lot of feature engineering that we have done here. So you can take a look at that, or even work through it, or you can add your own. This is in the GitHub file. That's now it's up to you. I think you have a good basis to go over that, and then you can work on your own. You can work on both the data sets. The crime data set, we haven't done much with it, and you can work on the property data set. And it's all in the GitHub file. Okay, so that's it for the webinar. I did take 1.5 hours. If you have any questions, please feel free to ask questions right now. The next session, for questions later, if you have any questions, please do join us on Slack and ask on the Help Me channel. We will be available, all 4 of us will be available on #HelpMe channel, to help with the questions. And do tag it with #mini-data-science questions so that we'll be able to get to you. And you can join us on Slack here. Please make sure to join us on Slack. And we have an upcoming data science bootcamp next week. That will be the last one for this series. And Sumana will be taking that. It will be creating and comparing the ML models. Please do register on the link here, the bit.ly link here. We will be sharing on LinkedIn and Slack and everything. So, and we do have an offset session coming up. Please do choose the time best to you. Suganya has a question. When you start analysis, do you usually know the specific question you're trying to answer? Sometimes you do, sometimes you don't, Suganya. So when you take a look at the data, you'll have questions like, for example, in the property data set that I have shown, yeah, like how Sumana said, it can be either exploratory or have goal based on a data set. So when you take a look at the data, you will have intuitive questions, and sometimes it will be questions from the customer or the person that you're going to give the project to, so it will be both. You'll have to combine both. You'll have to combine your intuition, and you'll also have to ask the person that gave you the data, or if you're working on a project. Don Walker has asked a question. Input Pandas SPD. Okay. DFPD, it's error bad lines is equal to false. Colab notebook and CSV are now in the same folder. This should be enough for the notebook to see the file, correct? Yes, it's not working. I'm getting an error regarding the file name. You're getting an error regarding the file name. Did that problem solve the answer? The question just went away.
Hey Anju, Sumana here. I've answered that question in chat. I think a lot of people are having issues loading their data sets, and they're not understanding that they have to download the data, load it into their Google Drive, and then change the link that's there in the Python notebook. So I've shared an answer. I'm going to reshare it in the chat too, on the instructions and how to get the authorization code, enter it, put the data in your Google Drive, link it to your Google Drive and get that working. And if anyone has any questions and can't get this working later too, please reach out to us and send us screenshots on what issues you're facing. We'd be more than happy to help you out with it.
Yeah, sure. Please do ask us. Yeah. Maroon has asked, what do you explore first in a data set to figure out the questions? You first explore the data. Usually first I do is try to look at the data and see if there are any null values, if the data is with the right D types, like the data types, all this I do. And then it's sometimes very intuitive. So when you look at the data set, sometimes it just comes to you. When you know the goal, or the goal to solve the problem, there are many questions that come to you which are very intuitive, and you'll be able to do that. But first, whenever I get a data, I first figure out whether the data is clean. I only work after I figure out if I can clean the data, and then I do feature engineering, trying to figure out with different columns, what are the different features I can get. But that will happen actually after visualization. So I visualize the data and then try to see. Usually I use pair plot and heat map, which does the correlation. And with that, I do feature engineering. So that's usually the flow I take, but some people do it differently too. But usually that's how I do. First clean the data and then try to look at the data, ask some questions come intuitively. Okay, so when Don is saying he did all that.
Don, so please reach out to us on Slack. There's definitely some issue linking between your Google Drive and your notebook, and that's the only issue over here. So that should be easily sorted out. Reach out to us on the Help Me channel, and we'd be more than happy to figure out why it's going wrong and get you started off on the notebook.
Please do contact us, Don, and we are here to help. Suganya has asked a question, the real world advice in addition to tech advice code. Exactly the kind of thing that's so hard. I agree, Suganya. It was very hard for me when I first started. I had to, break it myself, and I wish somebody would have told me. So I make it a point now whenever I give webinars to make sure that I put in some of my real world experience too, so that, everybody else, I just want to spread the word. So yeah, it is usually you don't get that outside. Yeah. They're taking online courses. Thank you. If there are any questions, let me know. So we have the bootcamp coming up next week. Please do join us. Please register. We have increased the Zoom size to 500 participants. So because the first time when we had a limitation, but now we have increased the size, and we are very grateful for all of you for joining us. And Helena, Debika, Swan, and I are preparing for another session too. So do share it with your friends, and if they are interested, they can join us. And also please put in your interest on Slack so we know which is the best time to bring another session to you. And you can join us on any of our social media. Please do retweet our tweets. Sumana, I would have shared the tweet. If you do, please do retweet us so that our sponsors do get the shout out, because without sponsors, we are a volunteer organization. Sponsors help us a lot. We'll be here for a few more minutes. If you have any questions, please reach out to us on Q&A, or Slack is open. Please, you can. I think they already shared the link, or you can use the QR code here and join us on Slack, and you can ask your questions on Slack. Do type in hashtag mini data science bootcamp, so we'll be able to get to your questions quick. Thank you. Thanks, Tom. Thanks, Harini. Thank you for joining. Thank you for your questions.